Hi everyone, good afternoon. This is Fengshi, and today my topic is identification of key influencers for secondary distribution of HIV/ST among Chinese MSM, a machine learning approach. This study is co-authored by many of my colleagues, and the corresponding authors is Dr. Qingpeng Zhang and Dr. Weiming Tang. If you have some questions about this study, you could contact corresponding authors or contact me. First of all, I will introduce some study background, some notes. This study is actually the founding and base of identification of verification of MSM key influencers during secondary distribution of HIV/ST, a machine sample learning based quasi-experimental study. And this study has been presented by my colleague yesterday in Parallelization 2 Digital Approaches. So if you are interested in the public health background and in the domain knowledge of HIV/ST secondary distribution, key influence identification, you could have some review of that presentation. And this study is the machine learning modeling part of that study, working as the training set and the testing set of our whole study. And that study works as the prediction set with real-world cross-experimental validation. So this presentation will talk more about machine learning modeling with some technical details. This is the framework of this study. Simply introduce this study, and we used 4 machine learning models for predict selection and for modeling. And the 4 machine learning models are assembled as one ensemble algorithm to finally predict who are the key influencers in our HIV/ST secondary distribution. And to compare with our method, we use the conventional human identification used the leadership self-reported scarce cutoff methods. So, as I mentioned before, this presentation will concentrate on modeling part. So what is machine learning? A good example is AlphaGo. AlphaGo is an implementation of machine learning modeling, and actually AlphaGo used reinforcement learning. It's a very advanced deep machine learning approach. And due to the sample size of our dataset and our trail, we just utilize 4 simple machine learning models in our study: logistic regression, support vector machine, decision tree, and random forest. And the same logistic regression in the general data analysis and in machine learning modeling. What's the difference? In general data analysis, logistic regression is just used for analysis the relationship of all variables yi and xi. And but for machine learning modeling, some samples are used for parameters training, and the remaining samples are used for testing. And if we have the future x201, x202, we will use the model and the x201, x202, and so on to calculate or to predict the value of y202, 201, 202. So the aim of this study is to provide such a predictive model for the following quasi-experimental study. So this study served as the training and the testing parts. About the results of this study, we present the machine learning classification results using 5-fold cross-validation, and we would say the ensemble machine learning achieved the highest accuracy and FE score in three types of key influencers identification. Key distributors refers to index who could distribute more than or equal to 2 keys to authors, and the key detectors means indexes who could help us to find positive authors, and the key promoters means that index who could help us to find some newly tested authors. And we could see that the ensemble machine learning achieved the highest accuracy no matter in which types of key influencers identification. And also, if we identify the same number of key influencers, uh, the based on our survey data, uh, the one certain human identification happened to classify 49 key influencers, and in and our ensemble machine learning approach also happened to classify 49 key influencers in 5-fold testing sets, and they are the same number. So such comparison is comparable, and we could see that uh, machine learning approach could distribute more keys, could help us to find more positive authors, could help us to find more newly tested authors. And we also run a simulation experiment. The simulation is just to simulate the course experimental, but based on some assumption, we can use computer programming to simulate, and the simulation results is also demonstrate the intervention efficiency is improved by our machine learning approach. So, in summary, our approach outperformed human identification no matter in average accuracy or to find more keys, find more newly tested authors, or find more positive tested authors. That's all. Thank you.